Welcome friends to the tutorial series, and today we perform an experiment which is router on a stick. So we will configure InterVlan routing by using router on a stick. Now the router is configured to do InterVlan routing between VLAN 10 and VLAN 20 as shown, and acts as a router on a stick in this topology. So you can see the arrangement. Here we have a switch, a multi-layer switch, which is connected to two PCs, that is the end devices, and we have a router connected to it. So this particular router is known as the router on a stick. Here we'll configure the router as follows. So here we have the VLAN 1, which is the management VLAN with subnet 10.1.1.10/24. We have VLAN 10 and 20, which are the user VLANs with subnets 10.1.10.0/24 and 10.1.20.0/24 respectively. The router will be configured with the last IP address in each of the subnets. The switch will have the address as 10.1.1.253/24 only, and then we'll configure the links between the switch and router, and finally we'll make sure that the PCs can ping each other. That is, we'll try to ping from one VLAN to other VLAN, and we also try to ping from the PC to the switch and from the PCs to the router. So let's get started. So here we start with the router configuration. Now firstly, okay, in the in this figure you can observe that the interface gigabit 0/0/0, the one which is connected from the router to the switch. So we'll make sure that it is up, because the state can be down. So we need to use the command no shut, which will activate the state from down to up. Then we'll start by creating sub interfaces. So the commands are shown, and I'll explain each of them as we go. So for the interface 0/0/0, we make this sub interfaces here, which is gigabit Ethernet 0/0/0.1, that is 0.1 here, and we use encapsulation .1q 1 native. We specify the encapsulation of .1q here using VLAN 1 as the native VLAN, that is the management VLAN by default. VLAN 1 will be the management VLAN by default, and we give an IP address which is 10.1.1.254, which is basically the last IP address in this particular subnet of VLAN 1, because we need to configure the router with that, and the mask would be 255.255.255.0. Next, we create the other sub interface. So interface gigabit Ethernet 0/0/0.10. Now here you can also use .2. I have used .10 as basically the number of the VLAN only to make it easy. You can use it is other as well. So again we specify the encapsulation as .1q, and using VLAN 10, we do not specify native here, and then the IP address would be again the last one for the specific VLAN, which is 10.1.10.254, and then the mask 255.255.255.0. And finally for VLAN 20 we make a sub interface as well and do the same. So this is the configuration of a router. You can go into the enable mode, and I'll run the show run command. We can see for the hostname router 1, it will show all the commands which I've already executed. Yes, and you can see that we have the interface 0.1, 0.10 and 0.20 already configured. For 0.1, it's the encapsulation .1q1 VLAN 1 native and the IP address as specified. Similarly, for 10 and 20, you can observe. Next, we start the configuration of switch. So we'll see the IP default gateway part later. Before that, make sure the interface VLAN 1 is active again. So run the no shut command, and then we start with the interface 1/0/1. That is the one, this particular link, the interface connected to the between the switch router, and we use switch port trunk encapsulation .1q and switch port mode trunk. In the previous VLAN deployment video, I had talked about the .1q encapsulation and the trunk mode. So in brief again, there are two modes, basically trunk mode and access mode. The access mode connects the switch to the end devices, and the trunk mode basically does all the management. It's used for management because we are using the encapsulation .1q. So whenever we want to forward a packet from one VLAN to another VLAN, so the switch should know the traffic should belongs to which VLAN. So for that, so to know about the VLAN that the traffic belongs to, it uses the encapsulation .1q. Here the packet frames do not have anything, so the packet frames are basically attached with a VLAN identifier that tells about the VLAN the traffic belongs to. So that happens in switch mode trunk. So the interface 101 is defined as trunk, while the next interface 1/0/2, that is, and 1/0/3, that is the ones which connected to the PC. They are simply the access modes. So we define switch port access VLAN 10, that is in VLAN 10, and switch port mode access switch port. That's about the interfaces. So we configure the interfaces connected to the router as well as the connected to the switches, to the PCs. Sorry. I'll go to the CLI of the switch and I'll run this command. Yes. Now you can see the interface 1/0/1, which is the. So to know more about the information, I have run the command show interface G1/0/1 switch port. Basically, it shows that this switch port is enabled and it is the operational mode is trunk mode here, and the encapsulation used is .1q, and the access mode is here VLAN 1. You can also do it for any other interface, say G1/0/2. Here we see that this is interface 1/0/2, which has a static access, and yes, its the access mode is VLAN 10, and it is an access mode and not a trunk mode. So I have already configured, and hence I can show the commands which I have already done. Next we will, so we have configured the addresses. Now we go to the PCs, and in the IP configuration you can give the IP addresses. I have given as 10.1.10.1 and the default gateway, which is basically the address of the router. So default gateway is that whenever a packet's destination is not understood clearly, the switch will simply forward it to the default gateway. So in this case 10.1.10.254, and the same is the DNS server. And the fast Ethernet, you can see the IP address given to the PC is 10.1.10.1. Similarly, I've done it for the PC2. You can see it's 10.1.20.2. So now we'll try to ping the router from the switch. So okay, now I'm using the command no IP routing, which is a by default enabled uh, you know feature. So by default you will find no IP routing enabled in the switches, that is no IP routing. And then I'll try to ping the router. You can see the success rate is 100%. And I can even ping any one of the PCs. Let's try the first PC, 10.1.10.1, and I ping, and you can see that the success rate is there. That is, it is. So we are able to ping from a switch to the router and also from switch to PC. Now I will use a default gateway. So I use default gateway as 10.1.1.254. Oops, I need to write the command is IP default gateway. I missed IP. And then the address of the router, IP default gateway. So I've given an IP default routing, and let's write this command, which is IP routing. So we saw that when it was a no IP routing, then a ping from a switch to the router was successful. And now I have given the IP routing command. Now we'll try to ping. The PCs. Yes. Now we see that switch is unable to ping the PCs. Now why does this happen? The switch is unable to ping the PCs because this time I have used the command IP routing. So when IP routing is enabled, you cannot use the default gateway. I repeat, when IP routing is enabled, you cannot use the command default gateway. Hence, when it was no IP routing, you could we saw that the ping was successful. So now let me enable again. I'll try the other PC as well. 10.1.20.2. Let me confirm. Because IP routing is enabled this time, so the success rate is 0. We configure and we say no IP routing, and I'll ping the PC now, and you can see the success rate is 100%. Now it is able to ping. Now also I'll try to ping from one PC to another. So let me ping from the first PC to the second PC. So I go to PC, command prompt, I'll ping the other PC, that is 10.1.20.2, and you can see that it's able to ping. I'll try to ping the router now, ping 10.1.1.254, and again it's possible. I'll try to ping the switch now, ping 10.1.1.253, and even that is possible. To see the configurations of PC, you can type ipconfig, and you can see the configurations which are done. That is for the current PC1, that is the left PC, the IP address is given, subnet mask is given, and default gateway is given. So basically we saw that we were able to ping to the router from the PC, we were able to ping to the switch from the PC, and we were also able to ping to the other PC from this PC. So we basically designed this experiment to configure InterVlan routing by using this router on a stick. Thank you for watching and stay tuned for more videos. Bye.